Hello class, today we're learning about congruent triangles and our objectives are to use properties of congruence and to prove triangles are congruent by the definition of congruence triangles. As we go through this lesson, we're going to encounter some of this vocabulary: corresponding angles, corresponding sides, congruent triangles, and when we get to the end with the proofs, we're going to need the third angle theorem and the transitive property. So first of all, what does it mean for two things to be congruent? Well, geometric figures are congruent if they are the same shape and the same size. So the corresponding angles and the corresponding sides are in the same position, and the polygon has to have equal number of sides that we're talking about. So the things from one correspond to the things from the other, and they are equal. The two polygons are congruent polygons if and only if their corresponding sides are congruent. So if the sides of one are the same size as the sides of the other, then yes, they're congruent. So let's look at these two triangles and decide whether or not they're congruent. Well, first of all, we know that they are congruent because of the little, if you look at triangle ABC and triangle DEF there on the screen, that symbol between them with the squiggly line over the top of the equal sign, that means congruent. So they're telling us that these two triangles are congruent, and when that happens, the corresponding angles are the same. So corresponding angles, the red A corresponds to the red D there. So angle A and angle D are corresponding, and therefore they're equal. Then the red B would correspond to the E, and C corresponds with F. And they're color-coded to match that. Okay, and then not only are all three angles in it equal, also all three sides are equal. So we can look at the side of the first triangle AB where it has one hash mark, and that side is equal to the other side that has one hash mark, DED. So AB is equal to DE, and then BC with the two lines is equal to EF with the two lines, and AC with the three lines is equal to DF with the three lines. So this is true not only for triangles, but for whatever polygon we might happen to have. All of the angles in the first rectangle correspond to an angle in the second rectangle, and they're equal. So all the angles correspond. Angle P is equal to angle W, Q is equal to X, R is equal to Y, S is equal to Z, and all the sides are equal. Good. Now, this brings up the next interesting point, which is how we are naming these figures. Okay, how do we name a polygon? How do we name angles, that kind of thing? So to name a polygon, you need to write the vertices in consecutive order. For example, you can name this polygon PQRS, starting in the upper left corner and going counterclockwise around the shape. Or you could start in the lower left corner with a Q and then say QRSP. So it doesn't matter. You can start wherever you'd like and go around, all right? Or you could go around the other way, starting with the S in the upper right and say SRQP. So it doesn't matter where you start, and it doesn't matter which direction you spin in. However, you have to use the sides, the vertices that are corresponding, or that are consecutive. So you cannot go from P and cut across the shape over to R. Okay, so you cannot say PRQS. Okay, you have to travel along the outside of the shape. In a congruent statement, the order of the vertices is important because it indicates which parts are corresponding, which parts are equal. So, two vertices that are endpoints of a side are called consecutive vertices. So you have to use consecutive vertices like going from P to Q, not from P to T. Okay, so now let's see if we can use corresponding parts to identify all the pairs of all the equal angles and all the equal sides. You can do this even without drawing a diagram. If I look at what they've given me here, triangle PQR is congruent to STW, well, since the P is first and the S is first, okay, so what angles are equal? Since P is equal listed first and S is equal first, I can say that angle P is equal to angle S. And then since the Q and the T are both in the middle, I can know that angle Q is equal to angle T. And the R and the W are last, so angle R is equal to angle W. So use the congruence statement that's given to determine which parts are equal. And the same thing goes with the sides. You can say PQ, the first two letters of one, is equal to ST, the first two letters of the other. Oh, so now I have the middle and the last. So QR is equal to TW, or PR is equal to SW. So use the congruent statement there to figure out which parts actually go together. And on tests and stuff, they can try to trick you with this. Make sure that you are naming these in the correct order. Okay, so now that we can name these, there's two things that I want you to be able to do with these corresponding parts. And the first of them is to use corresponding parts to find missing information. So if we're given if we're given that triangle ABC is congruent to triangle DBC, let's see if we can find the value of x. So what we need to realize here is, first of all, after you've read the problem, look in the picture and figure out what they're asking you. So find triangle ABC. Okay, well that's that top half triangle, and DBC is the bottom half triangle. So you figure out what they're talking about, because really there's three triangles there, right? So they're not referring to the large triangle at all. They're just talking about the two triangles that make up the shape, and they're equal. So if we want to find the value of x, so when you look at this picture, we can see that marked in red where the C is, I see a box. Well, that means that I have a 90-degree angle there. Okay, so that means that that angle is 90. Now, instead of calling it C, because if I just say C, I don't know which angle I mean. There's two angles that are touching C. So I need to name the angle with three letters. BCD, angle BCD on one side, and on the other side, BCA are both right angles. And we know that they're right angles because that's the definition of perpendicular lines. So we know that those are both right angles 90 degrees. So therefore they're equal to each other, and according to the right angle theorem, they would be both 90 degrees. Okay, now, since I know that they are equal to each other, I can say that the measure of one angle is equal to the measure of the other one. This is an important step because it allows me to now put in what is the measure of angle BCA and what is the measure of angle BCD. Okay, if I look up on the picture, I can see that angle BCD is the one that has the 90 marked in it, and angle BCA is the one that's marked 2x minus 16. So I can substitute those into this equation. Okay, substitute values for angle BCA and the measure of angle BCD, and now I have this nice little equation which I can easily solve to find for x, which I can easily solve to find x. So add 16 to the other side and divide by 2, and we get that x is 53. And the last thing that I'd like you to be able to do with these triangles is to use these rules of congruence to show that two triangles are equal. In order to prove that the triangles are congruent, we need to know that all the sides are equal, all the sides should be equal, and all the angles should be equal. So that's what congruence means. Congruence means the same shape and the same size. So as far as the same shape goes, we're going to show that all the angles are equal. And as far as the same size goes, we're going to show that all the sides are equal. So I'm going to have to list out all the angles on one and show that they're equal to the angles on the other. And I'm going to have to do that step by step for all the angles and for all the sides. So, and this is really where we're going with this lesson. What we're going to be learning is how to write these proofs. When we do it, I'd like you to make two columns like this. One column on the left for the statements that you're making and one column on the right for the reason why that statement is true. So, first of all, when you start your proofs, you're always going to start, the very first line is going to be something that's given. We're going to start at the top with what is given to us. So the first reason on the right hand side there is always going to be a given. And the last reason, the last thing on the right side, on the left side, is always going to be ending with what you want to prove. So we start with what they give us, we end with what we're trying to get to at the end. So at the end, I already know my last statement is going to be that those two triangles are congruent. So, first of all, they told us that angle YWX and YWZ are both right angles. Okay, that means that those two angles are equal to each other. So that's my first angle. I have now said that one angle from one triangle, YWX, is equal to the angle on the other triangle, YWZ. Angles are equal. Why are they equal? Because they are both right angles. That's the right angle theorem. So, good. That's my first angle. Why do I have any more angles that are equal? Well, they told us that YW in the middle there is actually bisecting that top angle. So if it bisects the angle, that means it splits it into two equal pieces. So what two equal pieces is WY splitting the top angle into? Well, I have XYW on one side and ZYW on the other side. So the top angle at the top there has been split into two. So that's the definition of angle bisector. That's what it does. So now these two angles are equal. So I'm doing good in my proof. I'm going through the angles. On step 2 there, I have that one of the angles is equal, and on 4 I have another angle that's equal. I have one last angle, angle X on one side and angle Z on the other side. Okay, so the fact that angle X is equal to angle Z is because of the third angle theorem, which says that if we know two, the third one must be the same. Okay, so now we have listed all of the angles in the triangles to be equal. Now we're going to move on to the sides and see if we can list all the sides to be equal. Now, the first thing, they told us that W is the midpoint of that bottom line. Well, if W is the midpoint of that bottom line, now, which is given, so that listing that is step 6, now we can say that the piece on one side from X to W is equal to the piece on the other side from W to Z. And that is by the definition of W being the midpoint. Okay, so we've got one side the same. Now we can say both triangles actually share that side in the middle, YW. So since they share it, I need to say that YW for the one triangle is equal to YW for the other triangle. And that is reflexive property. Just like a mirror, YW is the same on both sides. And then lastly, YZ on one side is equal to YX on the other side, and that was given to us. So now I have stated that all the angles are equal and all the sides are equal, and that is the definition of congruence. So now I can reach my conclusion at the end and say that triangle XYW is congruent to triangle ZYW by the definition of congruent triangles. Wow, so that was a lot of steps and the video was longer than I intended, but we will do more of these tomorrow in class. Great job.